A quote from Neil deGrasse Tyson, "We have no idea what it is, but we can measure it." The farthest traveled probe of all time, Voyager 1, just made a startling discovery. Something returned to Earth that startled the scientists. Voyager 1 detected a strange buzzing sound coming from outside our solar system. But what is it? A previously unknown form of matter, an alien signal, or an interstellar quantum phenomenon? We can measure it, but we don't know what it is. Neil deGrasse Tyson expressed his excitement and dismay at the same time. This discovery shocked the scientific community because nobody had expected signals like these in interstellar space. This discovery was made by Stella Koch, a student at Cornell University. She and her team found this buzzing in the data from Voyager's plasma wave system, which measures how many electrons are traveling in interstellar space. Although the buzzing is extremely quiet, it's repeated so often that scientists believe this signal could finally give us important answers about how space between the stars really works. Stella Koch believes that the buzzing could come from gas interacting with stars, interstellar winds, and magnetic resonances. Did you know that there is a gentle wind between the stars? We always like to think that infinite black backspace is empty, but that's not true. The hum recorded by Voyager 1 could be caused by interstellar wind, which consists of charged particles flowing through the interstellar medium and interacting with the remnants of the solar wind. Or perhaps the signal is the result of resonances between the magnetic fields of interstellar objects and the probe itself. These resonances could generate oscillations that are perceived as humming. But now the question arises as to what interstellar objects could be. These could be small micrometeorites, for example, which regularly hit the surface of Voyager 1 and generate vibrations that are then registered as a buzzing sound. The humming could also be a kind of echo of old long-gone stellar explosions whose energy and particle waves are still traveling through the interstellar medium, creating a faint but measurable background noise. These remnants of supernovae, which may have occurred thousands or millions of years ago, would be a fascinating echo of the past. However, completely new objects in space that we are not yet aware of are also conceivable. In that case, the buzzing would be the first indication of a completely new discovery. Is Voyager 1 on the trail of a rare quantum phenomenon? The Voyager mission is considered one of the most iconic journeys of a man-made measuring instrument of all time. Launched in 1977, the probe has now traveled so far that the remaining radio contact alone is nothing short of a miracle. It takes more than 22 hours for a signal to reach Earth from the probe's location. If Voyager 1 encounters a strange phenomenon, we only find out about it 22 hours later. However, the strange buzzing was not directly perceived by the scientists. It was isolated from old data. The signal would not have been audible at all, but special computer programs were able to filter it out of thousands of pieces of data. There may be other secret signals and measurement results hidden in the data that we have not yet noticed. Some suspect that the buzzing or other data, which may be kept under lock and key, may be evidence of extraterrestrial technology. The buzzing could come from a distant extraterrestrial technology that sends signals through space. These signals could be a form of communication or even a kind of radar. Once again, there are no official investigations into this, only speculation. Other exciting explanations for the mysterious buzzing in space are quantum phenomena. Quantum fluctuations are constantly occurring at the subatomic level, with particles and antiparticles spontaneously appearing and disappearing again. These quantum fluctuations generate tiny vibrations which, although very weak in the vicinity of Voyager 1, could be amplified over long distances and perceived as hums. The idea describes a kind of quantum noise that is transmitted through the interstellar medium. These vibrations could also be amplified by quantum entanglement, a phenomenon in which two or more particles are linked together. In this way, this signal is truly like a mysterious hum of the universe trying to tell us something we don't yet understand. Such quantum phenomena could even be the portal to hidden dimensions or parallel universes. In string theory, which attempts to explain the fundamental particles and forces of the universe, it is hypothesized that there are additional dimensions beyond our known 4 dimensions. Sometimes these hidden dimensions could penetrate our space-time, causing measurable effects. These penetrations could create energy fluctuations, which then result in a buzz in the interstellar medium. There could be portals to these parallel universes that occasionally interact with our own universe. Finding such a portal would, of course, be a sensation. These ideas are viewed with skepticism by official science, but it's highly interesting to open up to these possibilities. So far, however, the official opinion is still that the buzzing is probably due to an ordinary interaction of the interstellar wind with the heliosphere of the Sun. Voyager 1 crosses the heliosphere. What hardly anyone knows is that our Earth does not orbit directly around the Sun in space. Rather, we orbit our star in a kind of safe, protective shell which scientists call the heliosphere. The Earth does not rotate freely either, but is bound to the Sun and embedded in a play of other planets, moons, and celestial bodies. All of this together makes up our solar system, and this system flies through the galaxy like a closed capsule. But even the Sun cannot move freely within the galaxy. It is bound to the gravity of other stars in the Milky Way, moves in relation to them, and is ultimately also guided by the center of the galaxy and other structural influences. How our heliosphere moves within the galaxy and what effects it causes what forces it is exposed to is still one of the great mysteries of cosmology. So you can imagine the excitement with which scientists awaited the moment when Voyager 1 crossed the heliosphere. On August 25, 2012, the time had come. Voyager 1 crossed the heliosphere, the outermost edge of the Sun's sphere of influence, and entered interstellar space. The boundary region is known as the heliopause, and it marks the boundary where the solar wind, a stream of charged particles emanating from the Sun, meets the interstellar medium and stops propagating. It took almost a year for scientists to be sure that the transition to interstellar space had really taken place. The entry was only confirmed in September 2013 as part of a study in the journal Science. Scientists were astounded, as they had imagined the end of our Sun's direct sphere of influence to be very different. The heliopause was supposed to gently fade away like the water on a beach. Instead, Voyager 1 reported flying through an almost solid particle barrier. This skin forms the actual closure of our solar system, and the discovery very probably underlines the importance of the heliosphere as a closed capsule within the galaxy. Researchers therefore did not know at first what was really the end of the heliosphere and the beginning of interstellar space. While crossing the heliosphere, Voyager 1 registered several other remarkable changes in the environment. First, the plasma wave instrument on board the spacecraft registered a dramatic increase in plasma density. This event occurred between April 9 and May 22, 2013, when a strong solar flare caused electrons near Voyager 1 to vibrate. These vibrations showed a higher particle density than in the areas directly inside the heliosphere, which was a clear indicator that Voyager 1 had finally reached interstellar space. Another sign was a sharp decrease in solar particles and a simultaneous increase in galactic cosmic rays. On the day of the actual crossing of the heliopause, Voyager 1 reported a 1,000-fold decrease in solar particles and an increase in cosmic rays of around 9%. These measurements finally prompted the team to officially announce the probe's entry into interstellar space. Another important clue as to how this capsule of our heliosphere is constructed was shown by the differences with Voyager 2. Voyager 2, the sister ship of Voyager 1, crossed the heliosphere on November 5, 2018, about 6 years after Voyager 1. Voyager 2 is equipped with a functioning plasma instrument that had failed on Voyager 1. Thanks to these additional plasma measurements, researchers were able to obtain even more precise and direct measurements. What could only be determined indirectly with Voyager 1 was confirmed. While both probes registered a significant increase in plasma density, there were clear differences in their observations of the magnetic field. Voyager 1 experienced no major changes in the magnetic field, which was quite a surprise, and Voyager 2 showed some subtle changes that again provided exciting clues about the nature of the heliopause. With the data, scientists can now better reconstruct how our solar system interacts with the surrounding space, what influences there are, and how the medium in which we are traveling with our star is structured in the first place. Voyager 1 was never meant to return to Earth. You may be surprised to learn that Voyager 1 was never designed to travel in an extremely cold and dense environment for over 40 years. The fact that the probes have lasted so long and the technology is still working perfectly is nothing short of a miracle. NASA is proud of its 2 veterans, even if there has been occasional opposition to the program. Cuts in the space budget almost meant the premature end of the mission. But the science made it incredibly clear that we humans need these two probes and the knowledge about space. Operating and maintaining the probes cost hundreds of thousands of dollars a year. However, the measurement results and the unique position of the two probes in interstellar space are priceless for research. The probes will therefore be with us for a few more years, provided they remain functional. In 2021, Voyager 1 suffered a dramatic failure, and for months NASA feared for the continuation of the mission. Some engineers managed to solve the problem, and the mission was able to continue. In spring 2024, NASA issued another statement saying that the mission was likely to end soon. Since fall 2023, the probe had been sending cryptic data that no one could read. In April 2024, the miracle was announced again: Voyager 1 is transmitting again, and the adventure continues.